What's up, y'all? I made this fractured torus thing, and it's like full of fire, and it burns in a circle, and it like is made with animation nodes. So I'm like so into this, and I want you to know how to do it because animation nodes are super tight. They're gonna take your animations to the next level. Get rid of this cube and replace it with a torus. Up this radius a little bit to 3. I'm gonna add a subsurf modifier to this thing, making it look real smooth, shade smooth. I'm gonna fracture this. Go to edit, preferences, add-ons, type in cell, make sure cell fracture is on. Hit F3, look for cell fracture, go from volume to uniform. I'll put the recursion at let's try it at 1. When you hit OK, it's going to break apart the torus into all these little chunks. Oh, wow. Did way more than I expected. Wonder how many it did. Who cares? Let's keep going. Let's make these things break apart a little bit with animation nodes. I'm gonna move this over. I'll take this torus. We don't need this torus anymore. Delete it. I'm just gonna delete it. I'm never gonna use it again. Gone. Okay, so now all we have left are these fractures of the torus. And we want them to like shrink in a circle. We'll start just by making them shrink in a circle. How are we going to do that? First, I need to know where to shrink them. So I am going to create an empty plane axis, and let's just put it at the top here. So this is going to tell us where to shrink our torus. Save this, go over here and go to animation nodes. If you don't have animation nodes, you have to download animation nodes. Find animation nodes, download it, go back to Blender, edit, preferences, install, find the zip file. Do not unzip, but just select the zip file, install add-on, and then go to animation nodes and make sure that it is on. Once it's on, you'll be able to find animation nodes right here, and you'll create a new node tree. First, we need to grab all of these fractures. So I'm going to click over here, and I'm going to go down to the bottom. I'm going to shift click. Now we have everything selected. Come over here, I'm going to press Control A. You can press Shift A. That gives you like everything to select from, but god damn, there's a lot of stuff. That's why animation nodes are so tight. Okay, Control A just takes you directly to search. Create list. No. List. No. Object list. Create object list. Okay. Oh, one quick thing, node tree. I'm going to change this from always to tree changed, frame changed, and property changed. Always means that if you look up here in this left hand corner, it's running consistently. I don't need that to be happening. I'm just going to do it when I change the tree, change the frame, or change a property in a node. I'm going to hide this, and I'm going to get rid of this input, and I'm going to use from selection. This is going to give us a massive list. I mean, there's, how many are there? 256. Hey, that's a good number. We need to loop through it, so I'm going to create a loop. Loop input. And I'm going to do a new iterator, object list, because we're going to feed an object list into it. This loop is called my loop, so now I have access to my loop, and this is where we're going to feed in the object list. Now, this object refers to an individual cell, and it's just going to run through this list, and anything that I do to this object is going to happen to all of the objects individually. A couple other things real quick. The index refers to which index you're on in the list. So starting with 0, if you're looking at this cell, this will be 1, 2, 3, and then iterations should be 256, which is the total number of iterations you're going to go through. Lists of 256 items. Control A. I'm going to grab a viewer. This is a great way to help debug and figure things out. Just plug in the iterations, and yeah, in fact, we do have 256. So I'll just hide that back there. Okay, I need a couple of things here. I need to know I need to know the transforms input. Okay, this will give me the location, rotation, scale of the empty, which is this little plane axis right here. And then I'm actually gonna grab another one. I'm gonna duplicate this, and I'm gonna get rid of the empty, and I'm gonna plug in the object. So we're going to know the location, rotation, and scale of the object in question. Now, I want to know the distance between this axis and whatever object I'm looking at. So I'm going to grab distance, vector distance, throw in the location and the location, and this is going to give me a value of 0.55126. Now what is this? This may be referring to the last object in the list. So if I move this axis around, nothing happens because the tree didn't change, the frame didn't change, and the property didn't change. So if I put always on there, get rid of that. Now if I move this around, it's updating, and I believe this is just showing us the last item in the list. So I'm going to turn this back off. Okay, hide that down there. Cool. Now that I have the distance, I want to get a math node, float math, and I'm going to make this a minimum and plug 1 in there. So now, let me just throw the viewer in here. Okay, so now I will only get values between 0 and 1, because 0 means that the axis origin and the fractured piece origin are in the same exact location. It's 0 distance away. As that grows, let me turn this back on. As that grows, as we get further away, the length is going to get longer, but I want to cap it at 1. Because you'll see why, but like, I basically just want to like cap this between 0 and 1. Let's add a transforms output. This is what's going to allow us to control the object. So if I just plug in the object here, this will give us control over all of these objects. Like if I want to change their scale, I can change it simply by changing these values. See, they all get smaller, they can get bigger, but I want to use this value to adjust that. So I'm going to plug that in. Woo! We got it! That's it. That's already working. Let me stop this always execution. Look at it. Oh yeah, that looks pretty good. Pretty good. And then we can just move this around. We can't just move this around. If I change the frame, I'm just gonna play the animation so that it is updating. And then as I move this around, let me move this around without moving the Z-axis. Yeah, that looks sick. Let's get this axis moving. I'm gonna grab the time info node. This is gonna tell us what frame we're on. Not only that, it is going to, if we go to the item and check the end frame, now we know how many frames there are. Let me grab a viewer. So this tells us we are on the first frame, and this tells us that there are 250 frames. We're going to divide these values so that we know our progress. Okay, let's throw that in there. Divide. Now, at 1, this, as we go through the animation, is going to move from 0 to 1. Once we've hit 1, we are complete. And that's great, because if we do end up changing this to 100 frames again, then once we hit 100, we are at 1. So we know exactly how far we have gone along. Next, I am going to grab the constant 2pi. So we'll need this to we'll need to multiply this with the progress and feed that into a sine function. Because, let me also multiply numbers. Okay, move these out of the way, get that out of the way, and oops, I'm going to pump this value into here, this value into here, and we're going to look at this viewer, and this is going to take us from 0 all the way up to 2pi. So now we have this animation that when we reach the end frame, we've gone all the way to 2pi, and when we pump this value into sine is now going to give us, it's going to give us between -1 and 1, starting at 0. And it just fluctuates between those values. I'm also going to get a cosine function. Oops, don't want that. And this is essentially going to do the same thing. However, it starts at 1, and it goes all the way down to -1, the halfway mark, which should be 50, and then it goes back up to 1. I'm going to take both of these values, and I'm going to use them for the x and y coordinates of our MT, and it's going to be tight. It's going to be so tight. Let's see. Combine vector. Okay, sine, cosine goes to x, sine goes to y, and then transforms output. This is selected, so we are going to click that, and it's going to give us that. We want to control the x and the y of the location. We're just going to feed that vector right into it. And now, why is the z value so low? But as you can see, we are now going around in a circle. Awesome. So awesome. And not only that, but it loops seamlessly because you're using the sine and the cosine functions. And if you want it to go in the other direction, you can just switch the values for x and y. I like this direction, clockwise, like a clock. Now, one thing that is bothering me, oh, I know why. This z value is not being affected by this because I haven't selected the z. So if I select that now, I can control this, but I want it to be at 0. Let's add a little rotation to make this look cooler. Map range. Okay, let's throw this value in here. And what this is going to do is it's going to take, so we've already clamped this thing from 0 to 1, and the minimum being 0, the maximum being 1. We want our pieces to rotate when they are close to the empty. So when they're close, the value is 0. And when they're far, the value is 1. So we actually want to flip this to 1 and this to 0. So it's just going to invert, which is super cool. I'm just going to plug this directly into the rotation. It's going to create this new node, combine Euler. And if I just plug everything in to here, you'll see that, let me just go one at a time. You'll see that these are actually rotating. I forgot to put this one in. What happens now? So now they all kind of like have this nice rotation. Looks pretty good. If you want to affect this a little bit more, you can create a new math node, throw this in here, and you can multiply this value, and you can make these things kind of like shatter even more. I mean, rotate even more. And then you might just plug this in here, plug this in here, and now they have like huge rotation. I don't like that. That's too much. I might pump it up to 2. Maybe 1.5. Really up to preference at this point. You can get a little sexier with the animation here by interpolating. This interpolation will give you, like if you've used the graph editor, this will allow you to change how this animates between 1 and 0. So maybe I want it to be exponential. Let's see how that looks. Maybe, so that's an ease out. I want it to ease in. And that gives us like a really hard, quick rotation. Maybe I want it to ease out and ease in. Maybe I just want it to ease out. You know, you can play around with it. And then you can actually do a similar thing for the I'm going to take this for the scaling. So I'm going to turn that back to 0 and 1. And let's see what's happening here. Oh, God. That's ruined everything. Why? Oh, God. I hate it. Quintic. Jesus. I'm gonna make this thing 240. Just kind of slow it down. See, I didn't have to change any keyframes or anything. It's just animation nodes do it for you once you do it for them. Let's shade this thing. Click, let's grab the Torus cell, get the material, and create a new material. And I'm gonna select all the rest of the Torus cells. I'll select them all except for the first Torus cell where I assigned the material. Now I'm going to control click on that Torus cell. And I am going to come over here. I'm going to control L and link the materials. Now all of the Torus cells have material 0.001. And we can see that working by changing the color of it. I'm going to change it to this nice kind of blue color, bluish. Let me bring this down a little bit so it looks sick. Cool. Now what we want is for these to glow red hot when they fracture. And we want to do it piece by piece. So, excuse me. Let's see, how do we do that? Well, first of all, very similarly to our animation nodes, we're going to need to know the position of the fractured piece compared to the position of the empty axis. Let's Shift A and search for texture coordinate. I'm going to duplicate this so that we can get both. And here I'm going to select the empty. So now we have the object coordinates of the empty, and then this will refer to the object coordinate of whatever cell piece. And we're going to again, let's get a vector math. And we're going to again calculate the distance between these two. And let's also create a new shader. Oh, well, here's our mix shader. So we're basically going to be mixing between this principled BSDF and this emission shader. And this emission shader, we want to be kind of like this orange, this intense orange color. We can pump that in right now, and it looks really bad, but let's go to our render settings and let's create bloom, ambient occlusion. Let's pump up the strength. Very good, something like that. Cool. Now that we're going to be mixing between this and this. We're going to do that. I'm going to pump this into here, this into here. And then we are going to use this distance value, which can be anywhere between 0 and as far away from the axis as possible. We're going to put that into the surface and see what that looks like. Okay, very interesting. Okay, so now as we play this, yeah, we're on the right track. Looks pretty good. We also want to affect the strength of this thing. So if it's close, now in this case, if it's close, which means a distance of 0, then the strength is going to be 0. And if it's far, then the farther away it is, the brighter it's going to get. So we actually want to do the opposite of that. Map range, plug that in, and I'm going to say I want between 0 and 1, I want when we're at a distance of 0, that's the closest possible, that's going to be our max value. I'm going to put in like 175. And then when we're furthest possible away, I'm going to put this real close to 0, not quite 0, but I'm going to make it like 0.2. Cool. So now if we just kind of go around, as you can see, like we're like specific pieces are starting to glow as we go around, and as it gets closer and closer, it gets hotter and hotter, melts away. And then it cools off and gets back into the torus. Pretty cool. I'm gonna get another map range node here. Map range. I'm gonna plug that in here. It's doing nothing at the moment, but I want to, why do I want to do this? I want to just play with like how far along should it start glowing. See, I can bump up this max and I can start messing with it a little bit. And I think I'm just gonna bump this thing up to 1.4. And that'll kind of heat that thing up. I'm going to take down the bloom a little bit. The bloom is a little intense for me. Let's just pull this down. Something like this. Yeah. Ooh, that looks nice. Then if you want, you can add, like, you can kind of rough up this this shell a little bit. Just add maybe a little noise texture and math node. I'm going to subtract some value. Why am I going to subtract some value? This noise texture is going to give you random values between 0 and 1, with the average being 0.5. So you can kind of play with where you want your values to be. You can move them up and down, making the average whatever. You can make the average 0 if you subtract 0.5. Let's pump this in. I'm gonna subtract 0, so it's unchanged. I'm gonna put the roughness in, and now you can kind of see some roughness on here, and then you can just kind of play with how much you want it to be rough and how much not. So maybe something like this. Then you can also play with like the noise scale. Just kind of, yeah. Just give it a little texture so it doesn't look, I don't know, brand new, I guess. play with it. And there you go. Almost done. Shift A, add a plane, scale that up, look through your camera. Okay, looks good. I'm going to move the plane down on the Z axis. A little shadow there. That shadow looks a little rough, so I'm going to go into these render settings. Ooh, screen space reflections, yes. Motion blur, sure. Shadows. I'm going to up this cube size to 2048 so it's nice and sexy. The camera, I'm going to make it 1080 so that we can make a sweet Instagram square image. Select the camera. I'm gonna go here to view camera, to lock camera to view. This way I can zoom in, I can kind of get the angle that I want. Something like that. I'm gonna come over here and make another 3D viewport. Look at the very top. Turn this into a spotlight and move it, I don't know, something like right here. Move this over. To here. Maybe bring it down a little bit so that that fire really glows, you know what I mean? But there's enough that we can see this shadow. And then you can hide overlays and then kind of get a picture of what you're looking at. That's it. That's how you do it. That's how you make a fractured torus that's flaming on the inside. I hope you learned something today. I hope that animation nodes are a little less mysterious. And I hope that if you like this video, you'll like and you'll subscribe. I have like 0 subscribers, so I shouldn't say that. I shouldn't say that. Should I say that? I don't. I don't have any. You could be the first. Anyway, I hope that you like what you saw, and see you in the next one.